Good morning, children. So today we will learn how to find rational numbers between two given rational numbers. So before that, let me give some examples. I'll write two numbers now here, 3 and 10. Yes. So in between 3 and 10, how many whole numbers you have? So in between 3 and 10, you can tell we have 4, 5, 6, 7, 8, 9. Isn't it? So we have 6 whole numbers between 3 and 10. In the same way, if I write minus 3 and 3, how many integers are there between minus 3 and 3? So again you can tell we have minus 2, minus 1, 0, 1 and 2. That is 5 integers between minus 3 and 3. These things you can tell it easily. But now can you tell in between 1 by 2 and 3 by 5? How many rational numbers are there between 1 by 2 and 3 by 5? No, you cannot tell. It is difficult. You have not learned this. Okay. So today we will see how to find rational numbers between two given rational numbers. In between minus 3 and 3 or 3 and 10, in between that also we can find rational numbers. And you must know that in between any two numbers, even minus 3, 3, 10, all these are also rational numbers. So in between these two or these two, there lies infinite rational numbers. There are infinite rational numbers between any two given rational numbers. Okay, so now we will see how to find the rational numbers between two given rational numbers. Now suppose 1 by 2 and 3 by 5 itself we will take. So first thing you have to do is make the denominators of this same. Okay, so to make it same, you can take the LCM of 2 and 5. LCM of 2 and 5 is 10. So now 1 by 2 I can multiply with 5. Okay, so I have 5. So 1 into 5 is 5. 2 into 5 is 10. In the same way, 3 by 5. Now here we have made the denominator as 10. So here also we have to make the denominator same always. Okay, so 5 multiplied to 2 gives us 10. So if you have multiplied here 2, here also 2. So 3 2s are 6 and 5 2s are 10. So now compare the numerators, children. Compare the numerators 5 and 6. Compare the numerators in between 5 and 6. Now in between 5 and 6, can you write any other whole numbers? No, it is not possible. So what we can do is we can multiply 1 by 2 and 3 by 5 to a greater number than 2 and 5 so that our numerator increases, because now in between 5 and 6 we cannot find any whole numbers. Okay, so let us divide this 1 by 2 and 3 by 5 to a greater number so that our numerator increases. So I can make now 5 tens is 50. In the same way, 2 multiplied to what number gives you 50? 2 multiplied to 25 will give you 50. So I will multiply now 1 by 2 into 25 here and here also into 25. So 125 is a 25. 2 into 25 is 50. In the same way, 3 by 5 now. 3 by 5. I want to make the denominator same, 50. So I will multiply with 10 here. Here also with 10. So 3 tens is 30. 5 tens is 50. So now our denominators have become same, 50 and 50 here also. Now compare the numerators 25 and 30. So now we can write numbers between 25 and 30, isn't it? We can write 26, 27, 28, 29. Yes, so we can write 4 rational numbers between 25 by 50 and 30 by 50. That is nothing but 1 by 2 and 3 by 5. Okay, so in between 25 and 30, now I can write 26 by 50. Denominator will always remain the same. Whatever you have converted, same denominator you have to write. 27 by 50, 28 by 50, 29 by 50. In between means you must not write 25 and 30. Only in between that, 26, 27, 28, 29. So there lies 4 rational numbers between 1 by 2 and 3 by 5. Not only 4, like this we can go on increasing by increasing the denominators or the numerators by multiplying to a greater number. 10, 25 I have multiplied. You can multiply by any other greater number, but the denominators must be same. Okay, then you can write like this: infinite rational numbers in between any two given rational numbers. Let's take one more example. They may give you list 3 irrational numbers, list 5 rational numbers, 6 rational numbers between any two given numbers. Now they have asked between -2 and -1. You have to list four rational numbers between -2 and -1. Now -2 and -1 are integers. Integers also come in the group of rational numbers, we know. Okay, so now this we have to write three rational numbers between these two rational numbers. So firstly you can write it in the form of rational number, that is p by q, -2 by 1. Okay, so now I can multiply by any number here. Okay, denominator both the sides is 1. -1 also can be written as -1 upon 1. So the denominators are same. So multiply by any numbers. For example, now I will multiply with 6. Any number you can take. Okay, so you will get here -12. 1 into 6 is 6. In the same way, here also you multiply with 6. Here denominator is 6. So next also denominator must come same. So multiply again by 6. Okay, so you will get -6 upon 1 6 are 6. Okay, now denominators are same. So compare the numerators, -12 and -6. So write the numbers which come between -2 and -6. So you will get -11, -10, -9, -8, -7. Yes, all these numbers you will get between -12 and -6. They have told to write 3, but we have got 6. So any 3 you can write. So like this you can increase these numbers and get infinite rational numbers between any two given rational numbers. So you can write the 3 rational numbers between -2 and -1 are -11 by 6, -10 by 6, -9 by 6. Okay, 3 they have asked, so write 3. If they have asked more, you can write more also. Okay, so in this way you have to write the rational numbers between any two given rational numbers. Let's take one more example. Write 5 rational numbers between -1 by 2 and 2 by 3. Okay, exercise 9.1, first main fourth one, you have this question. Write 5 rational numbers between -1 by 2 and 2 by 3. So as I have told you, you have to make the denominators same. Okay, so to make the denominators same, now to LCM of 2 and 3 you can take as 6. So to get 6 I have to multiply by 3 here. 2 3s are 6. So here also 3. You will get -3 by 6. Then next is 2 by 3. So now here denominator is 6. So for next also you have to get 6. So to get 6 I have to multiply here by 2. So here also with 2. So 2 2s are 4. 3 2s are 6. So denominators have become same. Now compare the numerator. -3 and 4. Okay, so how many rational numbers you have between -3 and 4? We have -2, -1, 0, 1, 2 and 3. Yes. So in the same way you have to write, you can write the 5 rational numbers between -1 by 2 and 2 by 3 are -2 by 6. Okay, write the statement are -2 by 6, -1 by 6, 0 by 6, 1 by 6 and 2 by 6. 5 they have asked, so you can write 5. Okay. So in the same way, if you multiply to a greater number but the denominator must be same, you can get many more rational numbers between any two given rational numbers. Now next we will see how to represent rational numbers on a number line. Okay, so you know what is a number line? Yes, this is a number line. In between you have 0. To the right side you have all the positive integers and to the left side you have all the negative integers. Okay, now you have learnt in your previous classes how to locate integers on the number line. That is how to locate -3. Where to locate -3? Yes, -3 is here. So this is -3 on the number line. 2 on the number line. Here is 2 on the number line. So you know how to locate the integers on the number line. Now next we will see how to locate the rational numbers on a number line. So as we have learnt, in between any two numbers there lies infinite rational numbers. So in the same way here also on the number line, in between any two of these numbers there lies infinite rational numbers. Between 1 and 2 there are infinite rational numbers, infinite points and infinite rational numbers. In the same way between -2 and -3 there lies infinite rational numbers. So now how to locate these rational numbers? Now for example, the rational number is 1 by 2. how to locate this 1 by 2 on the number line. Yes. So where to locate, in between which two whole number it comes. To find out that, firstly see whether the rational number is a proper fraction or improper fraction. Now fractions you have learned. In fractions you have two types, proper and improper. Now 1 by 2. 1 by 2 is an example of proper fraction. Yes. So whenever a rational number is a proper fraction, you must remember it always lies, the rational number always lies between 0 and 1. It may be 2 by 3, it may be 4 by 7. Yes, all these are examples of proper fractions. So any of the proper fractions always lie between 0 and 1. Okay, always lies between 0 and 1. Now we will see how to locate this in between 0 and 1. At which point will you locate this? Okay, now for example 1 by 2 is there. Okay, so what you have to do, whenever it is a proper fraction, it lies between 0 and 1. So you have to enlarge that part. Okay, here is 0. This left side we have all the negative integers, and to the right side we have the positive integers. Now we know that 1 by 2 lies between 0 and 1. So we have to enlarge this part, children. Okay, whichever in between which two whole numbers it lies, rational number, that part you have to enlarge it. And see the denominator. Denominator is 2 here. So make two equal parts with the help of the scale in between 0 and 1. Okay, two parts, equal parts. 1 part, 2 part. Okay, 1 part, 2 part. So here is 1 now, and remaining as it is, plus 1, plus 2, and so on. Now I have enlarged 0 to 1 part. In that 2 parts I have made, because denominator is 2. Now out of that 2, 1 part we have to take. Okay, 1 part. When you are moving right side, count from left side. So this point is here 1 by 2 on the number line. Okay, so whatever is the denominator, that many parts you have to make, and what is the numerator, that many parts you have to take and mark the rational number. Okay, in the same way, next one we will see. Next one will take 4 by 7. Now 4 by 7 is also a proper fraction where numerator is less than the denominator. So it also lies between 0 and 1. So enlarge that part. Okay, now for example, if this is 0, now see the denominator. Denominator is 7. Okay, so I have to make 7 equal parts in between 0 to 1. Okay, so I'll make 1, 2, 3, 4, 5, 6 and 7. Okay, so this is 0 and this is 1. I have enlarged this part. Okay, because it lies between 0 and 1. I have made 7 parts because the denominator is 7. I am representing 4 by 7. Here I represented 1 by 2. Okay, so 4 by 7. Out of 7 parts, 4 parts you have to take. 1, 2, 3, 4. So this fourth part is nothing but 4 by 7 on the number line. Okay, children. So in this way you have to represent the rational numbers on the number line. Okay. Now this is if it is a proper fraction. Now for example, if it is a mixed improper fraction. If it is an improper fraction, then how will you denote it on the number line? Now for example, take an example of an improper fraction, 9 by 5. Okay. Now 9 by 5 is an example of improper fraction. So whenever you have an improper fraction, you have to first convert it into mixed fraction. You know how to convert into mixed fraction. Numerator should be divided by the denominator. 5 ones are 5. 9 minus 5 is 4. So you get one integer 4 by 5. Okay. Now represent this on the number line. Okay. So now before representing it on the number line, which part we have to enlarge, we have to find out, children. Okay. So see the whole number what we have got here. The integer part is 1. So after that, which number comes? After 1 comes 2. So always remember it lies between 1 and 2. If you have whole number here 3, then it lies between 3 and its successive number, that is 4. If you get whole number 5 here, it lies between 5 and 6. Okay. So now we have understood that we have to enlarge the which portion? 1 to 2. Okay, if here is 1, then again see the proper fraction. 4 by 5 is a proper fraction. So make 5 equal parts again. 1, 2, 3, 4 and 5. Okay, remaining as it is. Okay, this is 0. I have made 5 parts because 4 by 5 it is 1, 2, 3, 4, 5 parts. This is 1. This is plus 2, plus 1, and so on. This is minus 1, minus 2, and so on. Okay, now out of 5 parts, 4 parts you have to take, children. 1, 2, 3, 4. Okay, so here lies the rational number 9 by 5. You have to write. Okay, 9 by 5. Okay, in the same way, if you have a negative sign here, if you have minus 9 by 5, then you have to go towards minus 1, a 0, and okay, wait children, one second. It was between 1 and 2. So we have to enlarge the part 1 and, so change the numbers here. Here should be 1 and here should be 2 because it comes between 1 and 2. So 1 and 2 portion you have to enlarge. Here you write 0. Okay, 0, 1, and in between 1 and 2, because it comes between 1 and 2, so make 5 equal parts. Out of 5 you have to take 4 and mark 9 upon 5. Okay, let's take one more example. Let's take one more example. Minus 8 by 3. You have to locate minus 8 by 3 on the number line. So first see which kind of fraction it is. Is it proper or improper? Now you can see numerator is greater than the denominator. So it is an improper fraction. So whenever you have an improper fraction, convert into mixed fraction. That is, you have to divide 8 by 3. Okay, so 3 2s are 6. You get the remainder as 2. So in a quotient is the whole integer part. Minus sign is there. So write minus 2. And remainder is numerator, divisor is denominator. Minus 2 integer 2 by 3. So now you can see the integer part is minus 2. And after minus 2 you have on the left side is minus 3. So it means that this minus 8 by 3 lies between minus 2 and minus 3. So you have, with the help of the scale, draw a number line and you have to enlarge which part, children? You have to enlarge minus 2 and minus 3. Now for example, if here is minus 2. Okay, minus 2 and next will be minus 3. That part you have to enlarge, and how many parts you have to make? 3 parts you have to make. Okay, so any equal measurement you can take. You can take 1 centimeter, 0.5 centimeter or whatever, but it should be equal measurement. Okay, so I have made 3 parts, 1, 2 and 3. So if this is minus 2, this has to be minus 3. So in between minus 2 and 3, the denominator is 3 here, so make 3 equal parts. Next is minus 4 and so on. Next will be minus 1 here, 0, plus 1, plus 2 and so on. This part we have enlarged because it comes between minus 2 and minus 3. Now it is left side, minus is there, so towards the left side you have to start counting. Out of 3 parts, 2 parts you have to take. 1, 2. So this is 2 parts. So here lies the rational number minus 8 by 3. Okay, no counting from here. Left side means you have to count like this towards the left side. Okay children, so in this way you have to represent the rational numbers on the number line. Thank you.